Hello everyone, and welcome back to another remote sensing lecture video. And in this video, what I want to do is I want to sort of take everything we've talked about up to this point, right? The idea of the remote sensing data set with spectral, spatial, temporal resolution, the idea that, electromagnetic radiation has different wavelengths and that we can use different bands to record different regions in an image, and this idea that the electromagnetic radiation does things on the Earth's surface, right? It's reflected, it's absorbed, it's transmitted, right? Those sort of interactions, right? All of that has been kind of theoretical up to this point. And what I want to spend this lecture series doing is tying all of that together in a very concrete way by talking about actual sensors and sensor platforms, right? How those ideas of radiometric resolution translates to data quality, how the number of bands translates to specific sensors, what sort of vehicles we put those sensors on in terms of satellites, planes, and drones, and go through some of the pros and cons of the different types of sensors that we have and the different platforms that we have, and then wrap up this discussion with sort of one of the most important parts of the entire semester. And that is, if you have a given task, something that you're trying to do, how would you go about deciding what the best imagery for that application is? Walk through a workflow that I find is extremely useful for deciding out of the hundreds of different sensors that we have available to us, right? Which one do I choose? And that's going to be sort of the end goal here. Is talking about all the different pros and cons, how all of these sensors relate back to the theoretical content we've talked about before, and then wrap up with how do we make concrete choices based on that information. So the first thing I want to do is I want to talk about the different types of platforms, right? We have a sensor, we have to put the sensor on something in order to have it go collect information. And we're going to really talk about three different types of sensors, or three different types of platforms. And the way that I find it best to sort of categorize these is relative to how they relate to the surface of the Earth. Right? So we have Earth. Right? And then on Earth, we might have a person, right? A person's on Earth. This is just a normal person. And we want to have these different platforms that we are able to put these sensors on to be able to go out and actually collect imagery. And in this course, we're going to talk about three different platforms. And we're going to sort of categorize them based on their distance from the Earth. So right basically above a person, right, you can look up and you can typically see these things, right? We have the drone. And again, we're going to go into more detail in each of these, right? Are going to get their own video. But closest to the Earth, we have the drone, and typically you're going to see these at around 100 to 500 feet. Right? These are the things that, I mean, it's a drone. Everyone kind of knows what a drone is. You look up, you hear some buzzing, you look up, and someone's flying a drone. Well, we can actually use these drones to collect remote sensing imagery, and they're actually the closest to the Earth's surface that we're really able to get outside of you taking a picture with your cell phone. So we can use drones to gather very, very high resolution imagery. Okay. Right. And so we sort of go up a step from that. Right, we go up a step from that, and we get aircraft. Right? This would be, if you were to stick a camera on the bottom of a plane, and this is something that a lot of companies do. They'll actually take imagery using planes. Right? And planes typically are about 1,000 feet to about 10,000 feet. Right, so these are much higher than drones. And as a result, they have high spatial resolution, but it's not as good as the drone. And again, we're going to talk about different platforms in more detail. And then finally, right, as we go up, right, the drone, we go up to the aircraft, then we start to get to the atmosphere, right? Atmosphere. And we talked about the atmosphere in previous videos, and we talked about how important that is in terms of the data quality. Right, so we're passing through the atmosphere, we get out of the atmosphere, and now we're into the realm of satellites. Okay. And closest to the Earth, we have what are called sun synchronous. Right, sun synchronous satellites. Right, sun synchronous satellites, and these are about 375 to about 500 miles, right? So this drawing is not perfectly to scale, right? Drones and aircraft deal in feet. Satellites do start dealing with miles. So we go through the atmosphere and at about 350 to 500 miles, right? We're dealing with the sun synchronous satellites. And we'll talk about what sun synchronous means in the next video. And then we go way out, right? And again, this is not really to scale. Right, we go way out. We get what are called geo synchronous satellites. Right, geosynchronous satellites. And we're going to talk about what geosynchronous means in the next video. But these have a very specific distance, and they are specifically 22,236 miles. Okay? So these are the four types of platforms. We have drones, aircraft, sun synchronous satellites, and geosynchronous satellites. So these, by and large, are the four different platforms that we're going to be putting sensors on. And we're going to talk about each one of these in more detail. So hopefully this makes sense. Hopefully this breakdown makes sense. And again, we're going to talk about each one in more detail. So if any of this was confusing, just hold on, watch the next couple of videos. But as always, please reach out. Thank you.